Okay, hi. Hey guys, it's Mr. Morrissey. This is the first time I've done a screencast or flipped video from Bedford High School. So you should have downloaded from the Google Drive Circles and Ellipses if you've already read it over. That's a good thing. And let's see, hopefully you haven't, you're doing this around like 5, 6 o'clock, 7 o'clock. Don't know what TV shows are on tonight, Monday night. Oh no, what's today? Tuesday? No, today's Thursday. Anyway, we should get going. So I assume you've seen the handout, and we are going to start with question 1. Show that the circle with center h comma k um, and radius r. Again, I'm standing up here using the smartboard, so it's a little bit different. I have to get used to this. I don't know if there's going to be any music today. I don't think I can incorporate that, so just bear with me. Uh, Okay, so show that the center is hk, the radius is r, where r is greater than 0. Show that the graph is x minus h squared plus y minus k squared equals r squared. So let's see. Whoops. Let's see. So let's pick point h comma k, and that's going to be our center. And let's draw in a circle, and we'll call this point x comma y. There's our picture. So we're going to know for sure that using the distance formula, voila, we're done, right? That's it. That's what we were trying to show. That's the formula that we're going to use for a center, for a circle. The center is going to be h comma k. And the radius is going to be, the radius here is going to be the square root of whatever the number is right here. And let's practice that. So in number 2, remember you can pause at any time. I know I've said that 1,000 times. Graph x minus 2 squared, y plus 3 squared equals 9. So that's going to be another circle. The center is going to be 2 comma negative 3. So, well, you know what I can do? See, this is great. Now that I have the smartboard, I can erase. This is really great. Insert. Na, na, na. Okay, so it's so funny. So, thank you, thank you. Whoops. Hold on. Okay, so that's our old friend. It's our old friend here, the graph. So 2, negative 3. So there's the first point. What exactly are we doing? Okay, this the radius here. So the radius is 3. You could label a couple points. But there's our circle. Okay? Keep going. Okay, let's go to the next one. 3. Sketch an ellipse having the equation x squared divided by 9 plus y squared divided by 4 equals 1, and note the minor and major axes. Okay, so an ellipse, if you read the notes, is basically like a circle that's either been stretched horizontally or stretched vertically, and an ellipse, a circle is also an ellipse. We'll do a lot of practice with these kinds of problems in class, and we're going to start here with a basic one. Here, whoops, this is going to be in the form x squared over a squared plus y squared over b squared equals 1. And in terms of an ellipse, the a squared is always going to be the bigger number. So a equals 3, b equals 2. A couple things I want to point out. The number, I guess I can't point to it here, so I'm used to pointing. The 1 here, it always has to be a 1. when you write the equation in standard form. And let's see, since the since 9, it's really, this is really weird. I'm trying to point, and I know I can't point. Since 9 is the bigger number, this is a horizontal ellipse. And here's how you're going to draw the graph. So we want to, let's just do a rough sketch. So the horizontal ellipse, this is an ellipse that's centered at 0, and um, the A term is 3. So there's a point. 3 and negative 3. So 3 and negative 3 are the vertices. And then your notes mention covertices. Covertices are going to be the B points. So 2, negative 2. So I know this is not the best looking graph, but those are covertices, covertexes. And we're just going to draw something that resembles an oval. And an ellipse really is just an oval. So you can see that this graph, this ellipse is stretched horizontally. So it's not a circle, but it looks pretty close to a circle. It says note the major axis. Major axis. Well, that's 2 times A. And in this case, A is 3. So that's 6. The length of the major axis is 6 units. And the minor axis is 2B. So that's 2 times 2, so that's 4. To be or not to be, what does that mean? Oh, that is the question. Uh, let's see. So note the major and minor axis we did. We have a graph of the ellipse. We're going to take a break right now, and you'll do video 2 and have 2 more problems, including our favorite friend completing the square in a second. All right, we're gonna work on these screencasts. So this is my first one. All right, guys, I'll talk to you later.